All right, so section 23 is on solving equations using the unit circle. So I feel like a lot of pre-calc books do not cover this topic very well. So some pre-calc books are unit circle based, some of them are curve based, which we'll talk about. In this book that we have, it does not really focus in on this very, very well. But it's super important in AP Calc, so we're going to spend a lot of time on this in particular. So we have a couple sections that deal with just this. Okay, so number one, so it says use your unit circle to solve the following equations. Give every answer between 0 and 360 degrees. So the first thing is noticing that it says between 0 and 360 degrees. Okay, so we're doing this in degrees, not radians. And most of the time in pre-calc, you're going to do things in radians. Okay, and in AP Calc, we only do things in radians. All right, so we have from 0 to 360. So you should get to the point where you don't need to have your unit circle out, right? You should just be able to draw a little circle and tell what it is. So we did this, we kind of practiced this yesterday. We talked about, you know, what is the sine of pi over 6? And we draw a little mini unit circle and we say, oh, well, that's going to equal 1/2 then. You go up a little bit. Okay, do you guys remember doing that? All right, or 2 days ago, I guess. So now we're going to go the opposite way. We're finding what angle or what radian measure gives us a sine value of 1/2. Okay, so in this case, we're looking for the degree measure. So we say, when is sine of an angle equal to 1/2? So we draw a little picture. What this is saying is, where do you have a y value of positive 1/2? And you actually have more than one answer. Okay, so we have right here and right here, right? So we're going to be a little bit above the axis, just 30 degrees above. So the first answer is going to be 30 degrees. What's the other answer? 150, because you're 30 degrees away from 180. Does that make sense? So your answers for x are going to be 30 degrees and 150 degrees. So don't get confused that I have an x instead of a theta. I can put a theta. X is not like the x coordinate on the unit circle or anything. It's just an angle. Saying sine of some angle gives you this. All right, so same idea on this one. So what if sine is equal to √3/2? So it's saying the y value is a positive √3/2, so it's the big y value, right? So I draw a little sketch. Tyler, are you with me? So I draw it out. So I have 60 degrees, and then what does the other one have to be then? No, it's going to be 60 degrees away from 180, right? So it's 120. Does that make sense? So we're 60 degrees away from 0, and we're 60 degrees away from 180 as well. So we get x equals 60 and 120. All right, and then the next one. This is where it starts to get a little bit difficult. I never liked the tangent ones when I was in school. Okay, those ones I think can be a little bit hard. But we know that if I have a square root of 3 in it, then I have to be like either square root of 3 over 2 divided by 1/2, or I could be 1/2. Oops, that's weird too. 1/2 divided by √3/2. Okay, so I have to be one of those two things. Does that make sense? So I need to figure out what each of those are. So as I figure out this first one, I'm going to do square root of 3/2 times 2/1, right? Dividing by 1/2 is the same as multiplying by 2/1. And the 2 actually cancel, so we get √3. So this first one works out to be √3. But the second one, I have 1/2 divided by √3/2, so times 2/√3. It works out to be 1/√3. And, you know, a couple days ago we talked about how some of you are going to be super fast at rationalizing. What is this going to be if I multiply by √3/√3? Yeah, it's going to be, I multiply by √3/√3, so I get √3/3. Okay, so that's what the second one equals. Okay, so what form do we have ours in? Ours is in the √3/3 form. Does that make sense? So that means that we have to have a 1/2 for our sine, because tangent is sine over cosine. So we need a 1/2 and we need a √3/2. But they have to be opposite signs, right? One has to be positive and one has to be negative to create that negative out front. You guys see what I'm saying? So there are two places on the unit circle where this happens. So we're thinking of the y value being a little number, the x value being a big number. And they're opposite in sign. So let's think about the opposite in sign thing. Could it be in the first quadrant? No, because they would both be positive. What about the second quadrant? Yes, because you have negative and then positive. All right, what about the third quadrant? No. Fourth quadrant? Yeah, because positive and negative. So we're going to have here and here. Okay. Katie. All right, so what do we get? 150 again, and then what's the other one? 330. Do you guys understand how that works? So you kind of have to think about it. The tangents are a little bit hard. Think about which one it could possibly be. Is it 1/2 divided by √3/2, or is it √3/2 divided by 1/2? Okay? All right, so the next one. So now we're giving our answers between 0 and 2 pi. So we are in radians. Okay, this is what we will be most of the time, radians. Okay, but so it's the same thing. It's just giving our answers as radian measures. So now I have sine is equal to a negative 1/2. So it's saying where on the unit circle is my y value equal to a negative 1/2? Okay, so if you thought about it in degrees, it'd be 210 and 3/3, right? We're not doing degrees. You could always do the, if you panicked on the test, you could always convert. That's going to take forever, though, if you have a whole bunch of these. So it's best to kind of know these unit circle values. So we're 30 degrees past. 30 degrees is like pi over 6, right? So I'm pi over 6 past pi. Okay, think of fractions. 1 pi plus 1/6 pi. 1 plus 1/6 is what? 7 over 6, exactly. So we're going to have 7 pi over 6. Okay, because we did 1 plus 1/6 to get it. All right, now this other one is almost at 2 pi, right? It's going to be 2 minus 1/6. So that's 12 over 6 minus 1 over 6. Yeah, exactly, 11 pi over 6. So the only reason that some of you guys do not like radian measures is because you're not comfortable with fractions. You have to be comfortable with fractions in order to do radians. All right, so our answers are going to be the 7 pi over 6 and 11 pi over 6. Okay. All right, so the next one. So cosine of x equals negative √3 over 2. So we're saying our cosine, or our x value, is negative. Yeah.
How is it 7 pi over 6?
Because it's past pi. Pi is right here, and you're 1/6 past it. So you have 1 pi plus 1/6 pi. So it's 6 over 6 plus 1 over 6. Does that make sense? So you get 7 over 6. All right, so the next one. So we're at negative √3 over 2 for cosine. So we have two places where our x value is negative. √3 over 2. All right, so again, that's like 30 degrees away from 180 in both directions, okay? So what I have is pi over 6 away from pi in both directions. So if I have pi minus pi over 6, think of 1 minus 1/6, right? We get 5/6, so 5 pi over 6. And the other one is 1 plus 1/6. So that's the 7 pi over 6. So those are our two answers. So we get 5 pi over 6, and we get 7 pi over 6. All right, and then the last one is tangent of x equals negative √3. This is different than the last one, than part C from before, right? That was when we had √3 over 3. Okay, if we just have √3, then that's not this one on the right. It's the one on the left. It's the √3 over 2 divided by 1/2. Does that make sense? Okay, so we want √3 over 2 divided by 1/2. So we want our sine to be in the form √3 over 2. And we want our cosine to be in the form 1/2. Because then if I multiply by 2 on the top and bottom, I get √3 over 1. Right? And we want it to be opposite signs. Okay, so again, when we think about the quadrants that we can possibly be in, it's the second and the fourth quadrants. Right? So second and fourth quadrant. And we want our sine to be the bigger number. Okay, so it's going to be there and there. Remember how tangent has a period of pi? That's why it ends up being exactly across the unit circle from the other one. Okay, so let's think about it. Are you guys getting better at your radian measures? This is like 60 degrees away from 180. So it's like we had pi here, and we have subtracting out pi over 3. Right, so 1 minus 1/3 is going to give me what? 2/3, right? So 2 pi over 3. And this other one is going to be pi over 3 away from 2 pi. So if I have 2 minus 1/3, then think of it as 6 over 3 minus 1 over 3. This is the 5 pi over 3. Okay. So see how it can be useful to like memorize these different radian values. Okay. Yep.
I didn't know it was that specific one. Because there are a lot of values in the unit circle that have a cosine of 1/2.
Okay, but they don't. Well, no, there's only 2 values that have a 4 cosine. Well, if you have cosine equals positive 1/2, there's only 2. It would be here and here, right? But we don't want positive 1/2 necessarily. We want the signs to be opposite each other. We want one to be positive, one to be negative. Okay, so there's only 2 places that can happen, in the second quadrant and the fourth quadrant. Okay, where sine and cosine are different, where the x and y coordinates are opposite each other. Oops. So we get 2 pi over 3 and 5 pi over 3. All right, so it says in order to solve a trig equation, you're going to try to isolate the trig function. So you're trying to get like sine of x by itself, cosine of x by itself, whatever. Okay, so it's just like these last ones. It's just maybe it looks a little bit more complicated when you start. So if you have cosine of x plus root 2 equals negative cosine of x, then we just solve it like a normal equation. We're going to subtract cosine of x. So we get root 2 equals negative 2 cosine of x. And we divide by negative 2. So we get negative root 2 over 2 equals cosine of x. Okay, now it's in the form that we just did, right? We just did the ones that look like this. So we're saying when on our unit circle is our x value equal to negative root 2 over 2. So it's the ones that are in the middle there. So like the 45-degree ones, they're in there.
So 5 pi over 4?
So this one's 5 pi over 4. What's the other one?
3 pi.
Yep, 3 pi over 4. Does it make sense? Because you're 1/4 pi away from being a pi. Okay, so those are our values for x. So 3 pi over 4 and 5 pi over 4. Now I didn't tell you to do this in degrees or radians. So if I don't say that, assume that it's always radians between 0 and 2 pi. So that's what I wrote here. So if it isn't specified, use radians. Okay? All right, so number 2. So find all solutions of tangent of x equals root 3. We actually just did this one. I need to edit this problem. So this is saying tangent of x equals negative root 3. Which was exactly what number 2C was, right? Tangent of x equals negative root 3.
Can you go to number 1 of the second part? I think you got it wrong.
All right, so we have...
Is it negative root 2 over 2, you have to have opposites. 5 pi over 4 are both negatives.
You have cosine, yeah. Okay, so our answers here are going to be 2 pi over 3 and 5 pi over 3. Because it's exactly the same as that last one. I should edit that problem. All right. Next up. Shh, guys. All right, number 3. So you can do this one a couple different ways. Okay, the first thing that you could do is you can add the 1 over and divide by 4. Okay, and this is kind of a funny notation. You haven't seen me write this yet. Sine squared x. Okay. Whenever we write sine squared, that's really the same as sine of x squared. Okay, like that. Sine of x all squared. Okay, we just get very lazy as math teachers and math people. We don't like to put parentheses on every single problem. Okay, so instead we kind of sneak it in there. Okay, do you guys see how this is not the same as sine of x squared, right? That would be sine of x is being squared like that. Okay, so that's why we write it the way we do. We put the square, so it's like, oh, the sine, the whole sine is being squared. All right, so if we have sine squared x, what that really means is sine of x all is being squared. So how do I get rid of the square? Just like normal. How do you get rid of the square? Square root, right? So we're going to take the square root of both sides. And whenever we take a square root, we always have to write a plus or minus. Don't forget your plus or minus. Everybody always forgets that on this. So we have sine of x equals plus or minus 1/2. All right, so what we're saying is when is the y value either equal to positive 1/2 or negative 1/2? So how many answers am I going to have? 4, exactly. I have sine is equal to positive 1/2 and negative 1/2. Those 4 locations. So we're going to get x equals pi over 6, right? What about the one that's right before pi? 5 pi over 6, 7 pi over 6, and then the last one is 11 pi over 6. Okay, those are your 4 answers. But what you can also do is you can recognize that this is the difference of 2 squares. So there's actually another way of doing this problem. Do you guys remember difference of 2 squares? Easy. If I have like 4x squared minus 25, we just break it up into 2x plus 5 times 2x minus 5. Right, we've done that a million times before. Right, that's what we can do on this one. So go ahead and write this method down because it's also another method that we're going to do. So we could recognize that we have the difference of 2 squares and we could factor. We could factor into 2 times sine of x plus 1 and 2 times sine of x minus 1. So if you FOIL it out, you have 2 sine of x times 2 sine of x. That makes 4 sine squared x. And then the outer and inner cancel, and then you have minus 1, right? So it works out. And then you can set each piece equal to 0. So you can say 2 sine of x plus 1 equals 0. And 2 sine of x minus 1 equals 0. So when you subtract 1 and divide by 2, you get sine equals 1/2. And you get, well, sine equals negative 1/2, and sine of x equals 1/2 for the other one, which gives you the same 4 answers, right? So we still have those answers. Yeah, they're the same thing. All right, so number 4. So it says find the solutions of the equation on the interval. So this is one where we have to factor it out.
Number 3, I'm confused what the 4.
So I divided it over on this part. Is that what you're talking about?
Oh.
And then I took the square root, yeah. All right, so number 4, so it says find the solutions of the equation. So we have secant squared x minus secant x equals 2. So I'm going to get everything on one side. So secant squared x minus secant x minus 2 equals 0. And this is just like a W substitution. So remember, we did W substitutions even with logarithms. We did that in that section as well. And we did it in algebra 2 as well. So do you guys recognize that this is really like, you could let W equal secant of x, and then you have W squared minus W minus 2 equals 0, etc. Do you guys see that? Okay. So we're doing that process, but I'm not going to write W. Okay, so I'm going to be a little sneaky. I'm just going to write, I'm going to say, okay, I need 2 sets of parentheses, and I need secant x and secant x. And I need 1 and I need 2. And I need my outer and inner to combine to be negative 1 secant x. So I need the negative in front of the 2 and the positive in front of the 1. Does that make sense? So I set each piece equal to 0. So I have secant x plus 1 equals 0. And I have secant x plus or minus 2 equals 0. So I get secant of x equals negative 1, and I get secant of x equals 2. And you probably don't like this problem because it says secant, and it's kind of weirding you out, right? You're like, wait, what's secant? Do you guys remember what secant is? Yeah, it's 1 over not sine, 1 over cosine, right? So we're going to have 1 over cosine equals negative 1, and 1 over cosine equals 2. So really all you have to do if you have a secant is you just take the reciprocal, and you set it equal to cosine. So what I'm going to do is, instead of cross multiplying and doing all that stuff to simplify, I'm just going to take both sides of the equation and I'm going to flip them. So when I flip them, I have 1 over cosine becomes just cosine. And then 1 over negative 1 is still negative 1. And then this one becomes cosine of x equals what? 1/2. You just flip it. You take the reciprocal. Does that make sense? All right, so now we think on our unit circle. So we're like, okay, where is cosine of x equal to negative 1? Where is the x value negative 1?
Pi.
X equals pi. Yep. And then what about cosine equals 1/2? Yeah, so think about it. Let's draw it. So Ian says pi over 3 and 5 pi over 3. Do you agree?
Yes.
That's right. You got it. So we have pi, and we have pi over 3 and 5 pi over 3. Those are our 3 answers. Make sense? So we can factor even with trig equations. All right, so same idea on this one. This one looks a little weird. It's like, wait, sine of x minus 2 equals cosine of x minus 2. Well, if I just add 2 to both sides, do you guys see how we just have sine of x equals cosine of x? So what does that mean on our unit circle?
45.
It's 45, but or is it all of them?
No, it's
What quadrants can sine equal cosine? Where can x equal y in the unit circle? Yeah, in quadrant 1 and quadrant 3. Does that make sense? So what we're saying is, where is x equal to y on the unit circle? Okay, so it's going to be right here and right here. So we're going to have x equals pi over 4, and the other one is going to be 5 pi over 4. Okay, getting used to it? All right, let's try a couple more. All right, so this one. I think I made a typo here. I think I wanted the 2 to be here and not there. So edit that. I think and there's another one that I made a typo on later. So it just makes it nicer. All right, so yeah, we're solving 2 cotangent of x, cosine squared x equals cotangent of x. Okay. So I usually say, what do you think we're going to do first? And then people are like, divide by cotangent. Okay, you cannot divide by cotangent. So maybe write yourself a note. Don't divide by cotangent.
Can you ever divide by n? Like divide by cosine?
We will with identity stuff, but we always need to make sure that that's not one of our solutions. So think back to algebra 2. If you had like x squared equals x, okay, a lot of people in algebra 2 tried to divide by x, and they would just be like, oh, x equals 1, right? Divide by x on both sides. You guys see it? X equals 1. Okay, but that's actually not the only answer, because what you would have to do is you would have to subtract the x over, and then you would have to factor out the GCF, and you would get 2 answers. You get 0 and you get 1, right? Does that make sense? 0 and 1, x squared equals x. Those are the 2 answers to that. Okay, so if you divide by x, you lose one of the solutions. It's the same thing with trig functions. You can't just divide out by something, because what if that was a solution? I could have cotangent of x equals 0. All right, so we can't divide it out. But what we are going to do is we're going to get everything on one side. Yeah, subtract it over. And then we're going to pull out the GCF, just like I did on this last one. Okay, so the GCF is that cotangent of x. So I'm going to pull out cotangent x, and then I have 2 cosine squared x minus 1 is equal to 0.
You have 2 cotangent of x.
Uh-huh. Good. So I pulled out the common factor, cotangent of x. So I have 2 left, and I have a cosine squared. So 2 cosine squared. And then I have the 1 left, right? Does that make sense? All right. So now I want to set both of those equal to 0. So I'm going to have cotangent of x equals 0, and I'm going to have 2 cosine squared x minus 1 is equal to 0. So let's start with the cotangent of x equals 0. Okay, we want to think of that as sines and cosines. Do you guys remember how we can write cotangent of x? It's the reciprocal of tangent, we know that. Yeah, so cotangent of x ends up being the cosine divided by the sine. Right, so yeah, you're thinking about where your cosine is equal to 0, right? Because we have a fraction equaling 0, so the numerator has to be 0. And so I heard someone over here say, was it Connor? Did you say it? Pi over 2 and 3 pi over 2, right? That's where cosine is equal to 0. So those are our first 2 answers. We have pi over 2 and we have 3 pi over 2. Because cotangent is the same as cosine divided by sine. So I rewrote it. And I said, okay, I have a fraction that equals 0. The only way for a fraction to equal 0, right? So I have like 0 over 5, that's 0. Is if the numerator is equal to 0. Right? I don't worry about the denominator at all. All right. So now I have 2 cosine squared x minus 1. So I can't like factor this one. It's not the difference of 2 squares because it's 2, not 4. But I can add over and divide by 2. Right? And then I can take the square root of both sides. So when I do that, I always remember my plus or minus. Don't forget that. So I have plus or minus the square root of 1/2. So I take the square root of the top and the square root of the bottom. So I get 1 over root 2. So what is that? Plus or minus? Yeah, it becomes root 2 over 2, right? So cosine of x equals plus or minus root 2 over 2. So on our unit circle, how many answers do we have for that?
4.
We have 4 answers for root 2 over 2, plus or minus, right? So we have the 4 45-degree angle ones. So those answers are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. This one had 6 different solutions. Tricky, huh? I know, they get hard. All right, so 7 and 8. How about you guys try 7 and 8?
It was soft.
Uh-huh.
How'd you get root 2 over 2 if you're taking the square root of 1/2?
So when I took the square root of 1/2, I wrote it up there. I took the square root of 1, square root of 2, so I got 1 over root 2. And then I rationalized it. I multiplied by root 2 over root 2. All right, so you guys try the next 2. So number 8, you'll pull out a common factor. Oops, one thing. All right, here we go. So the first one, you guys should factor with 2 sets of parentheses, right? So you should have 2 sine of x and sine of x, right? And that's going to multiply to be 2 sine squared x, okay? And then we need 1 and 1 to make that 1, but they need to be opposite signs. So when I look at my outer and my inner, I want them to combine to be negative x So I need a negative 2 sine of x and a positive 1 sine of x. Okay, so I need 2 sine of x plus 1 and then sine of x minus 1. All right, so when I set each piece equal to 0, I subtract the 1 and divide by 2. So on my unit circle, I'm saying, where is my sine equal to negative 1/2? So it'd be in 2 locations, right? So normally we would write 7 pi over 6, and we'd write 11 pi over 6 as our answers. So let's go ahead and leave that. But we're trying to get things on the interval negative pi to pi, okay, which is a little weird. But let's go ahead and do that, because that's what you're going to be most familiar with, is on 0 to 2 pi. And then here we have sine of x equals 1. So sine is equal to 1 at the top of our unit circle, so when x is equal to pi over 2. Okay, so we want all solutions between negative pi and pi. So that's like saying that instead of starting at 0 and going around to 2 pi, like we normally do, instead, we're starting at negative pi, and we're going through 0 and around to positive pi. Does that make sense? So we still have a full rotation of the unit circle. We're still including all of those answers, but our answers are all between negative pi and pi. Yeah, so Natalie.
When you multiply 2 sine of x by sine of x, why wouldn't it be 2 sine squared x squared?
Because it's like 2, and it'd be like sine of x squared. That's how we would normally like write it. But we don't write things like that in pre-calc. Instead, we avoid the parentheses, and we write it as 2 sine squared x, like that. So it's like, that's the same thing as sine of x in parentheses squared. It's kind of weird. I didn't like that when I first learned pre-calc too. Okay, so we're almost there. Okay, so we want all of our answers to be between negative pi and pi. So one of them is this one. We are good. Pi over 2. That's between negative pi and pi. Do you guys agree? Okay, so we don't want 7 pi over 6 to be where it is. That's too big. It's not on our interval. So do you guys remember when we talked about coterminal angles? Okay, finding another angle that's exactly the same location, just written a different way. So we have 7 pi over 6. We don't want that. We want between negative pi and pi. So exactly, we're going to subtract 2 pi. So when I subtract 2 pi, what I'm subtracting is, or sorry, that was positive 7 pi over 6. I'm subtracting 12 pi over 6. So Connor got it. It's negative 5 pi over 6. So I'm going to really write that as negative 5 pi over 6. And then what about the 11 pi over 6? What's that going to be? So it's over here. It's negative 1/6 pi, right? So negative pi over 6. So think about that. When we talked about negative angles, remember I told you it's exactly the same. It just goes the opposite way. So normally positive angles go like this, right? But if we have negative angles, we go this way. So if I have a negative pi over 6, that means I go back 30 degrees. Is that the same as 11 pi over 6? Yeah, it's exactly the same. Okay, so you add or subtract 2 pi depending on what you need. So those are our other two answers. Okay. And then on number 8, we want everything between 0 and 360, which you guys always like. You heart degrees. I do not like degrees. I can't even think in degrees. Like, it's really, really hard for me to go like back to degrees. All right, so for this one, so I'm going to pull out the common factor, which is cosine of x. So remember, I'm thinking of that cosine squared as cosine of x times cosine of x. So I'm going to have 2. Well, I'm going to pull out the cosine of x first. So I have cosine of x, and then I have 2 cosine of x plus 1. Do you guys see how that factored? So I set each piece equal to 0. So the first one, I have cosine is equal to 0, so that happens in 2 places. All right, that's the pi over 2 and 3 pi over 2. And then this other one is going to be cosine equals negative 1/2. So cosine is equal to negative 1/2 in 2 different places. So what are those? Ah, see, I told you I can't think of degrees. You would have gotten me. All right, so we're going to say 90 degrees and 270 degrees. It's really hard for me to do degrees. I always think of radians. All right, so what are these? The ones I just drew for cosine equals negative 1/2. So you're 60 degrees away from 180. 120 and 60 degrees past 180, 240. Good. All right, so those are your 4 answers. All right, does this make sense? All right, so we have just a couple more. Almost done. I know it's a long section. All right. I'm going to go ahead and make this a 0. It will just be nicer. So I'm going to make that 0. So number 9, I had another typo, so make that 0. All right, so I'm going to have tangent squared x minus 2 tangent of x plus 1 equals 0. Okay, I edited. Don't make that 4. It doesn't come out nice. It's not a unit circle one. All right, so when I have tangent of x minus 1 times tangent of x minus 1, that's how it factors. You guys see it? See how you get tangent squared? You get negative 1 times negative 1. Outer and inner combine to be negative 2 tangent of x. Katie, you good?
Yeah, yeah, I'm good.
All right, so I set each piece equal to 0. And it actually ends up being the same solution, right? It's tangent of x is equal to 1. Okay, tangent of x equals 1. We talked about this a little bit with tangent. Tangent is sine over cosine, right? So what we have is sine of x over cosine of x equals 1. What does that mean? Yeah, sine and cosine have to be exactly the same number. So x and y are the same number. You could also multiply the cosine over if you want to. We're saying sine of x equals cosine of x, right? So sine and cosine are equal to each other in the first quadrant and the third quadrant. So our answers are going to be pi over 4 and 5 pi over 4. Okay? All right, I'm going to pause this for a sec. Here we go. All right, so it says sometimes we have double angles or triple angles, etc. Okay, so we're going to talk more about these in later sections when we talk about trig identities. But there are ways to solve for them right now. So we don't have to do all the later section stuff. We can do it right now. Just remember that if you have 2x instead of an x in your problem, then you should find all of the answers on 0 to 4 pi instead of 0 to 2 pi. Okay, and then we're going to end up having the interval at the end. So it's kind of weird. Double the interval, and then we end up having all of our values. So let's just look at an example. Okay, so this one, if I'm solving it out, I'm going to have 2 sine of 2x. You can put parentheses around the 2x if you want. And divide by 2. So we get sine of 2x is equal to root 3 over 2. So we would know how to do this if it was sine of x equals root 3 over 2. We'd have no problem, right? We'd be like, oh, okay, I'm going to draw a little unit circle and so on. So that's what we're going to do. We're doing a w substitution. So we're going to say let w equal 2x. So what we really have is sine of w is equal to root 3 over 2. But what I said is whenever you have a 2x, you're going to double the interval. So we're not going to just find it on 0 to 2 pi. We're going to find it on 0 to 4 pi. Okay, so we're going to think about all of the places where I have root 3 over 2 after 2 rotations around the circle. Okay, so I have those 2 places, but there's going to be 4 answers. Do you guys understand what I'm saying? So the first one is going to be w is equal to pi over 3. And the second one is going to be 2 pi over 3. But we're not going to go around the circle 1 time. We're going to go around 2 times. So as I go around again, what do you guys think the pi over 3 answer when I add 2 pi to it? What do I get?
7 pi over 3.
7 pi over 3, exactly. It's more than 2 pi. I've now rotated around a full rotation and another pi over 3. So I have 7 pi over 3. And then if I add 2 pi over 3 to 2 pi, what do I get there? 8 pi over 3. Do you guys see how I got that? So I'm adding 6 over 3 pi and 6 over 3 pi to both of those answers that I had before because I'm doing another rotation. It's a coterminal angle, right? It's just the second rotation around. So I have those 4 answers. So that's what w is equal to. Okay, but if you remember, w was 2x. So 2x is going to be pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3.
So you divide by 2.
Yeah, so if I want x, I just take everything and I divide by 2. So I take all of those answers and I divide by 2. So I end up getting x equals, so think about it, pi over 3 divided by 2. Pi over 6, right? You're having to pi over 3. All right, 2 pi over 3 divided by 2. Be careful. 2 pi over 3 divided by 2 would be 2 pi over 6, which reduces down to Pi over 3. 7 pi over 3 divided by 2. And then 8 pi over 3 divided by 2. 4 pi over 3. Are all of those answers between 0 and 2 pi? Yes, they are. Do you guys see why we have to go from 0 to 4 pi first? Because we're going to end up having the interval length, or having all of our answers again. Yeah, Michaela? You get it? Okay. So basically, if you check any of those answers, it's like, you know, you could check it here. You're plugging in pi over 6, so you really have sine of pi over 3. Well, sine of pi over 3 is definitely equal to root 3 over 2. Does that make sense? Or if I check the last one, 4 pi over 3. I have sine of 8 pi over 3. Well, 8 pi over 3, right? 8 pi over 3 would be going around the unit circle once, 6 pi over 3, and then another 2 pi over 3. And that does equal root 3 over 2, so it works. But this answer that we had, 4 pi over 3, is on the interval 2 pi, 0 to 2 pi, so we needed it. Okay, so you cannot leave off all those answers. Okay, so same thing for the next one. So now we have a 3x. So what do you think we're going to do if we have a 3x? We're going to go around 3 times. We're going to triple the interval. So instead of going 0 to 2 pi, we're going to go 0 to 6 pi. Okay, so this one could have a lot of answers. All right, so we did the same process. So I'm going to subtract the root 2. I divide by 2, so I get sine of 3x is equal to negative root 2 over 2. So I think that this is a w, so let w equal 3x. And I find sine of w equals negative root 2 over 2. But I find it on 0 to 6 pi. So I go around the unit circle 3 times. Okay, so I have sine is equal to negative root 2 over 2. So down here and down here. And I'm going to have 6 answers. Okay, because I'm going to have 2 answers for every rotation. So I'm going to have w is equal to, that first one is 5 pi over 4, and the next one is 7 pi over 4. All right, we want to keep doing one full rotation around until we do it 3 times, okay? So let's think about this. If I have 5 pi over 4 and I add one rotation, if I add 2 pi, okay, I'm adding 8 pi over 4, right? Isn't that the same as 2 pi? So what's my next answer? 13 pi over 4. You guys see it? I added 8 over 4. And if I add 8 pi over 4 to this next one, what do I get? 15 pi over 4, exactly. All right, but now I'm going to go again. So I'm going to add 8 pi over 4 again. So it's really adding here. 8 pi over 4 to 13 pi over 4 becomes 21 pi over 4. And then the last one is going to be 23 pi over 4. Exactly. That 21 got a little congested there. 21 pi over 4. All right, does that make sense? So I now have 3 full rotations. Yeah, Katie?
And the reason you did 6 pi is because w is equal to 3x.
Right, exactly. So it's telling you how you're going to double your interval or triple your interval or whatever. So in this case, we tripled because we have 3x. So now, that's what w is equal to. So that's really what 3x is equal to, right? I'm lazy sometimes. I just say 3x because I don't want to write it out again for 3x. So I'm going to divide everything through by 3. So I end up getting x is equal to 5 pi over 12. Right, dividing by 3 is the same as multiplying by 1/3. 7 pi over 12. 13 pi over 12. What about this next one? 15 pi over 4 times 1/3. What does that become? Yeah, because it becomes 15 over 12, but that reduces. So it's 5 pi over 4, because that reduces down to 5. How about the 21 pi over 4? Yeah, exactly, because the 21 and the 3 reduce down to 7. So 7 pi over 4. And the last one, 23 pi over 12. Is 23 pi over 12, is it between 0 and 2 pi? It is. It's a little bit less than 2 pi. Do you guys see how all of your answers become between 0 and 2 pi? All right, and the very last one. So we're going to subtract 1. So I get 1. So I'm going to have sine of 2x equals negative 1. This one doesn't have very many answers. Where is sine equal to negative 1? So I want sine of w equals negative 1. But I want to go on 0 to 4 pi, right? Because I want to double the interval. So the first answer, right, is going to be pi over 2. So if I do one rotation around from there, so if I add another 2 pi, right, I'm adding 4 over 2 pi, so I'm going to have 5 pi over 2. right?
Pi over 2 at the top.
Oh, whoops, not pi over 2, 3 pi over 2. Thank you. All right, and then I get, so if I add, so 7 pi over 2. Oh, Will, don't forget to write your name in a little bit.
No,
All right, oh, it's Cameron. All right.
doesn't matter.
Someone will get a point. All right, so we get that. All right, so that's what W is. So remember, W is equal to 2x. So we divide by 2. So we get x equals 3 pi over 4 and 7 pi over 4. Those are our two answers. And that's it. Okay, so it's a pretty easy process. Just remember to double the interval, triple the interval, whatever you need to do. Okay, that was the last one, right?